All you just have to do is click on that point, and then the value will come up just like this. You can see the value of the shear force, and the same thing applies even if you are dealing with the bending moment. You can click at any point on the beam and you get the value of the bending moment. Hi guys, this is Chef Jin Academy. In this video, I'm going to be showing you a simple two-dimensional frame analysis tool that you can use to analyze beam, 2D frames, and trusses. This software is very easy to use and is actually developed by Luis Fernando Mata, which is a professor of Civil Engineering Department from Catholic University. You can read about him. This software has a paid version. With the paid version, you have access to other functions that might not be available in the free version. But with the free version, you can easily analyze and create more or less anything you want to do. So with this software, you have about 2 or 3 modeling tool. We have the insert member and you have the node. So this is actually the insert member where you can use to create members. You have the insert node where you can use to create node at different points, and then you can use the insert member to connect nodes together. We also have the keyboard mode. You can create models using ordinary node and insert member. You can even use the keyboard node to determine the coordinates of each of the members. So if you look below the software interface, you see grid. So you can decide to check this grid and you can decide to uncheck it. So when you check it, it makes your model easy, but you are going to see how that is possible in the next couple of minutes. So then we have the next, beside the grid, we have X and Y. This X and Y as the distance between the grid along the X and along the Y. So you can see it is 1 meter. So if you want, between this grid and this grid is 1 meter. So each of these grids is at 1 meter interval along the X and along the Y. But you can actually change these settings. Then the next after the coordinates X and Y is the snap. This snap allows you to snap into each of these grids, just like the way you used to do on AutoCAD. So, but the first thing we want to do is let's try to edit these settings. You can just edit the distance between this X and Y by just clicking on them. Let's say I want them to be in 0.5 meters. You see, when I do that, the number of grids increases. Then below the modeling tool is where we have the control tool, which are used to control your display. So you can just like the zoom in, zoom out, and each of those buttons. So when you create a models, you get how to use them properly. But before we create a model, one of the things you should understand is, the first thing is the sign convention. You need to understand the design convention of this software. So you can see what the software terms as a positive bending moment. You can see what it terms as a positive shear force. And then you can see what it terms as positive axial load. Because when you understand this sign convention, then you can know which one is compression, which one is tension. So that is one thing. Then another thing is the unit and number formatting. This is also important. You need to set your unit before you start using the software. And the best unit to use is the SI unit. The SI unit is default. That is, your length is going to be in meters, while your section sizes is going to be in millimeters and millimeter squares. Your forces is going to be in kilonewton. But if you are in the US, you can try to use the US unit, which include using the feet and the inches. Then you can also make use of the kilonewton meters unit. You are just going to stick with that. Then another thing is you can change the number of decimal points you want to have for each of these parameters. Like for the length, you have 2 decimal points. For displacement, you see you have 4 decimal points, and it can also be expressed in terms of 10 raised power something. So let's take a couple of examples. Let's analyze a simply supported beam that is 5 meters. You can do this using the grid, or you can even use the keyboard mode. So let us use the keyboard mode. For you to use the keyboard mode, you have to click on it and make sure it is active. So when it is active, then we can click on node. You have to create node first before you create other members of your structure. So if I click on node now, so the first thing I want to do is create the coordinate of the first node. So I'm going to use 0. I'm going to place the first node as 0, 0. That is x 0, y is 0. So I'm using a tolerance of 0.01. You can reduce this tolerance if you want, but it's not really going to affect your analysis too much. So let's click it at 0.0. So I've created the first point. So this is the first node. Then let's assume that my beam is 5 meters in length. So that means along the X, I'm going to put the second node at 5 meters. So I just click this. So you can see that you can now click on close by using this cross button. So you can now see that I've created two nodes. This is the first node, this is the second node. So if I want to bring this node to fit it to the screen, I can just use this fit to screen icon here. And this one is for like a refresh. Like in AutoCAD, we have regenerate, something like that. So these are the two nodes that I create. The next thing I can do is, let's say I want to create this, I want to connect this node with beams. All I have to do is click on insert member. But because the keyboard mode is on, so that is why you have to indicate the coordinate of your member. This might not be easy. So if you want to create member, it's always better to uncheck the node. You can uncheck the node, then you click on insert member, then you can insert the member between these two nodes. So this is my beam. So another way I can create a 5 meter beam is to use the grid. Let's say I change the grid line to 1 meters. If I change it to 1 meters, all I have to do is click on node. Once I click on node, then I can click on the first node, but you can see that my mouse is not really snapping to the node. This is because the snap is not checked. So once I snap the snap, then I can now click on this node. This is 2 meters, this is 2 meters, this is 3 meters, 4 meters, 5 meters, then this is 5 meters. Then I can now create a beam between this. So this is one way of this is another way of creating a member. You can either use the keyboard mode or you use the grid. So for the purpose of this video, I'm just going to uncheck the node, and then I'm going to delete this second member that I create. You can delete by just highlighting over, just like the way you have in AutoCAD, by highlighting over and pressing the delete button. So now we've determined the length of our beam, which is 10 meters. You can use this dimension line to determine the dimension of your beam by just clicking between the two nodes. You can see it's 5 meters. Let's say you want to change the size of this 5 meters. Maybe it's too small for you. You can come to display, or you come to option, then you come to text size, then you change it to large. So once you change it to large, you can see that the size of the dimension increases. You can remove the dimension by clicking on this select mode and then selecting the dimension and deleting it. So for you to analyze a beam, the first thing you have to do on this software is you have to follow everything from left to right. You can see from left to right, we have material parameters, we have section properties, we have support, we have rotation release, we have deformation, and then we now have the loading. So the first thing we have to do is to determine the material properties. So I've explained what we have on the left hand side. So on the right hand side, this display here actually changes depending on whatever icon you are clicking on. Like now I'm on material parameter, so that is where you have material parameters here, and here is where you can define different parameters, even though the software have about 2 or 3 generic parameters that are defined on the software already. But let's say you want to define your own parameter, you just have to input the elastic modulus of the material, you input the Poisson ratio, and also you input the thermal expansion coefficient. But what we are going to do is, I'm on material parameters. So for you to set a new parameter, you click on this button, create new material parameters. Once you do that, anything you want to do on this software, you have to give it a name. So in this case, so let's just label this as concrete. I just give it a name, but you can now select different material type. You have generic, isometric, you have steel, you have concrete, and you also have aluminum. So I'm just going to select concrete isometric, then I'm going to select done. So now I've created my material. So once I create the material, you can see the elastic modulus, Poisson ratio of that material, and the thermal expansion coefficient. So the next thing I have to do is I have to assign this material to a member, just like the way we used to do for if you are conversant with Start Pro or softwares like robot, you know, when you create a material, you assign it. So you select the material and you can apply it to all current member by selecting this icon. You can see this icon, apply to all current member. It has applied. It's another node. Let's say I have a node here. Let me use the snap. I have a node here and I have another node here. Then I have this member between this node and another member between this. Let me uncheck the snap. So now let's say I want to give this 2 column a different material. All I have to do is select this 2 column, then I can select this material, apply current material to the selected members. So to change the material, all you just have to do is use this drop down. If you had, let's say you have about 2 or 3 materials, you can add them and then you use this drop down to control. So but let's just delete this for now. So now that we've created a concrete material for our beam, the next thing is to go to section property. So under the section property, we do the same thing. We come to create new section property. So you can see here we have a lot of section property, but I will just stick with a rectangular section, because for a rectangular section, I just need to input the length, the width and the depth. But for an eye section, there are a lot of parameters I have to input. So I'm just going to say concrete rectangle. You can give this name anything, it does not really matter. So then you say done. After that, you have to input the depth and the B of the rectangle. So the B of my rectangle, so let me use the standard size of beam, 230 by 450 millimeters. So as I input the depth and the width, you can see it automatically calculates the center of gravity of the concrete section. Then it calculated the area. It also calculated the effective shear area and also the moment of inertia. All these things they are not really going to affect your analysis, but the way the software is created, you have to define it. So once I've created the section property, I have to apply it to a particular material. So I will just click apply to all current sections. So it has been applied. The next thing I have to do is to create a support condition. So in this example, I want to analyze a simply supported beam. So that means I have to define a pin support at one end and a roller support at the other end. For you to define a pin support, that means, you know, a pin support is free to rotate. So that means you need to fix the displacement along the X, you fix the displacement along the Y, and then you free rotation. That is the meaning of a pin support. Then all you have to do is you have to select the node in which you want to apply it. I want to apply the pin support to this node. So I select the node, then you click on apply to selected node. So once you do it, you can see the support is displayed. Then I want to apply a roller support to this node. So in a roller support, you have to fix only the Y. You fix only the displacement along the Y, because a roller support is free to move along the horizontal direction. So that is why you have to fix only the displacement along the Y. So if I do that, then I click on apply to selected, then you have your nodal support. You can actually create a fixed support. You can create a fixed support by, if I select this node now, I can remove the support by just clicking on this remove support condition. So let's say I want to put a fixed support here. In a fixed support, you have to fix X, Y, and also fix rotation. Then I select the node, then you can just click on this. You can see that the direction of the fixed support is not correct. So you can use this angle to rotate the direction of the fixed support by just changing this angle to 90 degrees, selecting the node, and use this apply support condition to the node. You can see it has changed correctly. So this is how you can define your pin support, your roller support, and your fixed support. Then you can even define string. So this is actually applicable for foundation design and some other complicated design, but we are just going to limit ourselves in this video to these 3. So let me change this support back to a roller support. So that means I'm going to free X and Z and then apply it like this. So the next thing I want to do is I want to create a node at the middle so that I can apply a concentrated load. So to do that, all I have to do is I can come to this keyboard and click on node, and instead of this, I just put 2.5, because 2.5 is the middle of of this and this. Then once you do that, you can see that it has actually divided the member into two. So after we've defined the support, then in this example, we are not going to talk about the rotation release and the deformation constraint. So let's just go to the loading part. So in order to load our beam, we can actually create a nodal load, that is a concentrated load, which can be in form of a moment, or we can even create a end moment, that is the moment at the end here, or we can create a uniformly distributed load and a uniformly varying load, as well as thermal load, which is temperature load. So in this video, I'm just going to put a concentrated load at the middle here. So let's use a concentrated load of 50. So just like the way we did for the materials and section property, we have to create a new load. So let's say I create a node of P equals 30 kilonewton as my load. Then I click on done. The name does not really matter, as I've told you. Then you come to F. You can see Fx is the load along the X direction. But because this beam is along the what? Along the X direction, though, that means the load that I have to apply to it to be along the Y. So if I apply a load of 30 kilonewton on this beam, and I select this node, and I click on apply nodal force to selected node, you can see that the load is acting upward. This is not the right direction. So I have to put minus here in order for the load to be acting downward. I hope you understand. So once I put minus, the load acts the way it's supposed to act. Then I can also create a moment along this node. All I have to do is select the node, and then you put a moment of maybe 2, just as an example, and you can see the moment at the node. But for this example, we are not going to apply any moment. So let's say I want to create another load at the middle point of this 2.5 span of the beam. I have to create a new load and create a new load. So far the load is not 30 kilonewton. I hope you understand. So after that, let us create a uniformly distributed load across the beam. So all you have to do is click on this uniform load. Then you click on create new load. Let's create a uniform load with W equals to 12 kilonewton per meter. So we click on done. Then all you have to do is you have to apply the load globally, because we are working with the global X and Y. So we select global direction. Then the load has to be applied along the Y. So it has to be minus 12 because it's along the Y. Then for you to apply it, you have to select the member. So let's say we apply just a uniform distributed load on this part of the member. Then click OK. You can see the load is being applied, 12, and the direction is downward. Then you have 30 kilonewton. So let's try another example. Let's apply a uniformly varying load, which is this. And for uniformly varying load, you have to define 4 things. So the first thing is, let's say our V for uniformly varying load is, the maximum load is 12 kilonewton per meter. Kilonewton per meter. Then you click on done. So the P here is the value of the force along the I, that is where the load is starting from. I is where it is starting from. Xi, where it is starting from along the X. So you put the value. So in this case, it's going to be 0 because I want to make it to be triangle. So if you want it to be triangle, all you just have to do is come to along the PJY. You just input a value of minus 12, and then you select the material and you click apply. Then it's going to apply. This is a triangular uniformly varying load. But let's say I want it to have a value at the beginning. I want it to have a value of maybe 5 kilonewton meters. So I have to do is I have to come to under PJI, that is the Y axis. I is the beginning, J is the end. So the start is the I. So along the Y, so I have to put a value of minus 5 kilonewton per meter. And then you see we have minus 5 here and we have 12 here. So once I've correctly defined my load, I can now easily see the shear force diagram as well as the bending moment diagram. So this is the result tab. You can see here we have the diagram result. This is the influence line result if you want to see the influence line. But in this case, we are just going to click on this shear force. So once we click on the shear force, the software will ask us to save the beam. So let me just save it as 230 by 450 beam. Then you say okay. So you can see the shear force diagram of the beam. So if you want to see the bending moment, you just have to click on this bending moment. Then you see the bending moment diagram of the beam. If you want to see the displacement, you just click on this displacement, but you can see that the displacement, you cannot see any value. For you to see a value, you have to click on this small triangle beside the displacement. So you can see, if you want to see the horizontal displacement, you can see horizontal displacement, even though, and value. If you want to see vertical displacement, you can see vertical displacement and the value. If you want to see the axial displacement value, you just select it. If there is, it's going to give it to you. But for the purpose of this video, let's just stick with vertical displacement value, because this is actually the deflection part of the beam. You can see the displacement is minus 3.6, is very small. Then another important thing about this software is, let's say you want to get the value of the shear force. I'm under the shear force now. You want to get the value of the shear force at a particular point along the beam. All you just have to do is click on that point, and then the value will come up just like this. You can see the value of the shear force, and the same thing applies even if you are dealing with the bending moment. You can click at any point on the beam and you get the value of the bending moment. But you can see here that I'm just clicking at a random point. But let's say I want to get the value of the bending moment at 1 meter along the beam. What I have to do is click on this, on the beam, and then you right click. So once you right click, you are going to see different things here, and then you now come to step. Change the step to 0.5. You are going to see that it's actually going to change. You now have at 0, at 0.5, at 1, at 1.5, at 2, and at 2.5. So this is quite interesting. Then let's play around with this software. So let's say we come to display, and then we want to show the reaction forces. We have to show the reaction at the support. All you have to do is come to reactions. You click on it, you can see the reaction. But if you want to show the value of the reaction, you see the reaction value. You click on it, and then you are going to see the reaction forces. This is 42.1 kilonewton, and this is 39.2 kilonewton. So if you click on the shear force, you can see the shear force diagram as well as the reaction. You see 42.1, and this is actually what we have here. Other thing you can do is you can even come here and come to step lines. That is, if you want to see based on the step that are defined here, which is step of 0.5, we want to see the value at 0.5. These are the steps. So if you want to see the value, come to display and you select step values, then it's going to show the values at different steps. So if you click on the bending moment, the same thing is going to happen. If you click on the displacement, the same thing is going to happen. So this is how you can simply analyze a simply supported beam. But let's say, for example, this our beam is a statically indeterminate. That is, we have another roller support here. So what are we going to have? But before we do that, let me uncheck all these things. So what we are going to do is, let's come back to support condition, and then let me remove the reaction forces and the value. So under the support condition, let's say we want to define another support here. You click on the mouse button to bring back the load. I click on this select mode so that I can bring back the load. Then I want to put another roller support here. All you just have to do is apply. So once I do that, you can see that my beam has now changed from a simply supported beam to a continuous beam. So if I click on the shear force diagram, you can see that the diagram has changed a little bit. If I click on the bending moment, see the bending moment has changed a little bit. You can actually play with it by showing the reaction forces. If you want to see the reaction now, see the reaction has changed. So the same way you can model 2D frames and trusses. So if you like what I've shown you, but before we end this video, if you like what I've been showing you, you can hit the subscribe button and turn on the notification so that when I make more video on F2, you get notified and you get to watch them. So let's say you now want to export all these results for your use. For example, you can, as a structural engineer, you can analyze with this software and export the results for use. One way of exporting the result is you can come to file, and under this export you see a lot of exporting that you can do. One of the exports is you can even export this as a DXF file. So all you have to do is click on DXF. Once you click on it, then you save it. So let's say I save it with the name of my beam, 230 by 450 beam, and I click save. Then you can now open the beam. You can also export as PDF by clicking on this PDF format. Then you can open it on PDF. I'm going to open all of this export so that you can see. But the only problem is it's only going to export what is on display. Let's say I want to export the shear force. You click on this shear force and you export. You cannot export everything all together. You cannot export the shear force, the bending moments on one page. You have to export it individually. That is the only downside that I found out on this software. The first thing we are going to open is, let's open the DXF file and open the PDF file that we exported and see what we have. This is the exported CAD file. All I have to do is right click and come to zoom, then select zoom extent in order to see the drawing. You can see the drawing. This is the reaction forces, and then this is the bending moment diagram. The shear force, the software is only showing the maximum bending moment. Unless you check the step, then it can show you the bending moment or the shear force at different steps along the beam. So let me show you the PDF export that I exported. So this is the PDF export. So you can see the PDF export. This is the bending moment diagram of the beam. So just like I told you, if you want to export the shear force, that means you have to check the shear force diagram and then you export it individually. If you want to export the displacement, you do the same thing. So this is how to use the F2. You can use it to analyze both statically determinate and indeterminate beam. You can use it to analyze 2D frames, in which I'm going to be creating video on that in my next video. And also you can also use it to analyze trusses. Thank you. See you in the next one.